Hello, this is Stacy Thomas from CS002. I'm going to be explaining experiment number 6, single pass assembly for SIC for system software incompatibility. This first we're taking hash table OP and then we're reading ready optable into the OP. Similarly for new hash table we're using SYM and then we're reading the buffer from the file, which is input and enter. This contains the code here, input and optat. So this is just being taken in from the two text files, and then over here it'll encounter string line and title, which is just an empty string, and then over here we're setting a local counter and then start to 0, and then here it is going to read if when the line is equal to BR.readLine, it will check whether if it is not equal to null, and then it will start. That just states that here, as you can see, when the start is encountered, it is just going to start reading. It's going to split it, and then it's going to store it into title, and it's going to check the length. And then it is after checking the length of the C string, it is going to store it into start, and then this is just going to change it into parsant, and the start is going to be stored into the LC. So after this, if it is equal to 3, it is going to start into LC. Otherwise, it'll start is equal to 0. Again, LC is equal to start. So this just means that if there are 3 here, it is going to show the if c dot length is equal to 3. So here in this case it is 1, 2, 3. So it is going to store it as 1000. If not, in this case it is, but if not, it is going to if it is less than 3 or not 3, it is going to show meaning this won't be there, and then it will show that it might be 2, so that it will start will be equal to 2, and then LC will be equal to the same value as well, and then it is going to be written. And then when it does not line contains and it is not it does not contain it, it is going to else equals pass symbol update, and it contains the parameters over here. So we're going to put a pass symbol update. And this the parameters are each taken in, and then it is going to split the line, store it, and then if it contains C at position 0, it is going to check for if it matches from A to Z with all the variables shown once, at least once, and then one time, and then if the symbol contains C at position 1, if it does not contain this, it is going to put this into it. So now this contains the symbol dot put, and then if it does contain it, now it'll show that it already exists. So if it doesn't exist, it'll put it into the file. If it doesn't exist, it'll put it into the file. If it does exist, it'll just show that it already exists, and it's going to write. Now that's if the symbol is contained. If it matches, it'll do this, and if it doesn't match, it's going to show that it is an invalid label name, and it's going to increment it. Again, else if the C at position 1 equals word, it is going to write it to hex string, and then the symbol dot put is going to do LC, and then it'll increment LC in 3 bytes. So it's just going to increment the LC over here because it is word, and then the same thing over here for reserve word, which is over here, reserve word. These are incremented in bytes of 3. So over here the same, it is going to write the integer to hex string, it is going to put the symbol into it, and it's going to increment the LC by 3, and it is going to change it to parsant. And over here, else if it equals reserve byte, it is going to change it to hex string, put the value in the symbol. So, yeah. sorry, Z in positional LC, and it is going to increment this one directly, just increments it without having to increment it by 3. It just puts it in without incrementing it by 3, and it is going to return the LC. So if we go back, so now once it returns the LC, it is if it does not contain the end. Now else if line contains it, it is going to write to integer hex string at position LC, and it is just going to print the line. So after that, if whenever we want to change it to hex string 26, it is going to just use the for loop, and then the word length will be given, and then if it is less than 6, it is just going to print 0 in the word, and it is going to return the word back to it. So over here, the pass2 is used after this to 6, and then after once it is split, that's when it is going to show the reserve word, reserve byte. Once it encounters the pass2, first it's going to be read, and then it's going to be written. So this is when the pass2 is going to be used. So over here, after the pass1, here, when the object code is encountered, it separates it, and the integer is written to hex string, and then else if the line contains reserve word, it is going to, the LC is going to be incremented by 3, again the same thing, and then the LC is going to be incremented over here for reserved byte, and then over here for the word it's just going to increment it by 3, and then it's going to print the object code. So this is the end of experiment number 6. Thank you.